In this video, we present ForceExtension, a novel way to extend the effective range of isotonic position-controlled multi-touch gestures with rate-controlled force sensing. Position control and rate control are most popular for mapping device input to output on the display. Taking an example of the touchpad input. Position control maps the movement of the finger linearly and precisely to the movement of the cursor. However, clutching is needed to rewind the input space to reach a faraway target when the finger reaches the boundary. Rate control devices, such as the IBM TrackPoint, avoid clutching by controlling the cursor's speed. However, controlling speed is less accurate and is easy to overshoot the target. Recent research has proposed hybrid solutions to combine the benefits of position and rate control by augmenting isotonic position control devices with a rate-controlled elastic ring, such as the bubble technique, the rubber edge, and the groove pad. When the finger touches the central area of the touchpad, the cursor moves on the display by position control. When the finger reaches the limit of the input space and starts pushing the edge region, the cursor gains a speed and starts moving towards the corresponding direction until the finger push is released. Unfortunately, these hybrid solutions cannot be applied to multi-touch gestures due to the limit of the device. Recent advances in multi-touch technology have enabled pressure sensing of each touch point on the multi-touch touchpad in addition to position tracking. The Synaptics ForcePad is a multi-touch force sensing touchpad that detects up to 5 fingers of variable pressure at 6-bit resolution and up to 1000 grams of force. Using this device, we can control the cursor's movement by position control as usual and switch to rate control whenever the force input exceeds a threshold, and the hybrid of position and rate control can be applied to multi-touch gestures as well. Based on this force sensing technology, we propose ForceExtension, a methodology that contains two novel approaches to extend the effective range of position-controlled multi-touch gestures with rate-controlled force sensing. In the context force extension mode, a force threshold is defined and position control is active before the force input reaching the threshold. The system triggers the transition to rate control when the force input exceeds the threshold, and defines the speed vector by scaling the most recent position control moment with the pressure input beyond the threshold. As shown in the video, position control from a small input space to a large display requires frequent clutching. The time and effort of clutching can be avoided using context force extension. The user triggers rate control by pressing down the touchpad whenever she realizes the limit, and returns to position control for accurate input once the target gets close. The shear force extension mode also triggers rate control only when the force input exceeds the threshold. However, instead of scaling the context movement, shear force extension tracks the microfinger displacement after the transition to rate control and scales it with the force input beyond the threshold. Using this mechanism, we have realistically simulated shear force sensing of multiple fingers. In the shear force extension mode, the user's finger does not perceptibly move, and since shear force is used, the direction of the speed vector can be changed without switching back to position control. To demonstrate force extension to multi-touch gestures, we have developed a 3D interaction application in Unity 3D game engine. Our full force terrain editor allows the user to edit terrain surface and manipulate 3D viewport using the Synaptics ForcePad alone. As shown in this video, The cursor is position controlled, and single finger force can be used to increase the terrain height. With another finger touching the bottom left corner, the terrain surface can be pushed down as well. The terrain brush can be resized by single finger movement while another finger touches the top left corner. Two-finger movement orbits the camera around the focal point. Pinch gesture can be used to zoom the camera in and out. And finally, three-finger movement pans the camera in all horizontal directions. To manipulate the viewport effectively, force extension has been added to camera orbit, zoom, and pan. This video demonstrates shear force extension. Context force extension can be applied to the game as well. A formal user study will be conducted in the future to compare the two extension approaches for various 2D and 3D tasks.